Okay, so hello everyone. I will be presenting User-Centric Networking, a new approach to designing a networking curriculum with my advisor, Jen. My name is Ross Teixeira, and a couple notes about me. To my students, I am not the Ross in Caroz and Ross. And to you all, unfortunately, there is now more than one R Teixeira in the community, so I apologize for any confusion that might cause. So in thinking about how to design a new networking curriculum, we started out with a few basic questions. First of all, we want to make networking really personal and really engaging for students. This is a question that's come up a lot in this discussion so far, and how do you make a course engaging and personal? And two ways that we settled on were, well, we want students to be able to conduct measurements from their own locales, understanding how the internet works in the real world and understanding what tools they can use to measure it and learn about it. And we also want students to discuss internet events, both historical events, things that have happened in the real world that have affected the internet, and also public policy issues surrounding the internet, and giving students an idea of and an understanding of how they fit in this bigger picture and how they might be able to shape the internet. And we also talked about what are the advantages of remote learning? We talked a lot about the issues where it's hard to engage students and students are across many different time zones. But at the same time, the fact that we now have many students at home with diverse vantage points at many different locations that are all using this common internet, this actually prevents an interesting perspective and a lens to view the internet and conduct measurements from the student perspective to learn something about the internet. So our goal for this curriculum is basically to take active learning to the max. We want to give students as much opportunity to engage with the internet itself by conducting measurements and from their own locales, and also engaging with discussions on public policy and historical events with the internet. And also these measurements across students can then be combined together to produce some class-wide statistics or this bigger picture about the internet that can then be shared with the class. And so if there's one thing you take away from this approach, what we really want students to do is, well, we want to not only empower students to understand their place in a worldwide network, but also to understand their role in shaping the internet in the future and what power they have for that. So our design is first motivated by, we want students to measure the internet as much as possible. So a lot of times networking curriculum is designed either top down or bottom up. You start at application level and you sort of work your way down to understand how the nuts and bolts work. Or you start at the bottom up, the fundamentals of, how does local transport work, Ethernet, and building up routing and reliable transport up to the top. But when students are conducting and reasoning about internet measurements, they're sort of naturally engaging every level of the stack. If you want students to measure the performance of an application they're looking at, for example, just browsing the web or watching videos, that can be affected at every level of the stack. Performance might be affected by the video compression algorithms that are being used, or the amount of concurrency in their browser. Comes down to whether they're using reliable or unreliable transport. And then, of course, there's issues in global routing, what paths they take, what congestion they experience. And so in order to design a curriculum around student measurements, we decided that we would introduce layering sort of fundamentally early on and get that out of the way, and then allow the curriculum to be driven by a user-centric perspective, where we start at the students' local network and just sort of having them understand, how they connect to the internet, the bootstrapping process, what other devices might be on their network, and then sort of spreading outward across all layers as students get broader and broader, where they start to understand now, well, what are the popular applications that are used on the internet and how do they work? Things like web browsing, video streaming, teleconferencing, which is, of course, very apt at the moment. And also introducing students to peer-to-peer networks with torrenting or chats like the Matrix protocol. And then moving more broadly out to understanding the routing infrastructure. Students can measure, understand their performance and what paths they take to different destinations on the internet. They can also look at if students are in diverse enough locations. You can study interesting properties like the asymmetry of BGP routing, or conducting longitudinal studies and sort of looking at what paths students take over time, or what CDN servers they encounter, all of these things. And then finally, getting to like resource allocation and understanding what happens when you have conflicting flows or conflicting programs on a computer. And so here students might run simulations to slow down things, change browser settings, or getting help from family, friends, roommates to help conduct experiments and understand how their traffic reacts to competing flows. And then we also want to generally make students better and more informed citizens of the network and the world. And so to do that, we want to engage students in public policy questions surrounding the internet, especially things that are relevant now in the age of COVID. Dan talked earlier about integrating computing and the news into courses. And so we want students to reckon with, for example, the fact that there are many students who don't have proper internet access. As instructors, that's a difficult part of the course, and how do we reach out to students? But for students, maybe they also don't realize these challenges. And so we think it's important for students to recognize that even their own classmates might have issues connecting to the internet, and discuss the ramifications of that. And we also want to have students understand past world events and how they have affected the internet, natural disasters, wars, political uprisings, and also talking about future events like climate change. So how does the world deal with thousands of miles of new undersea cables that weren't designed to work underwater? Probably not so well. Now, there's many challenges that go into designing a curriculum like this that we have to consider. So students have many different computers they're using, different hardware, different OSs, they're in different locations. So how do you get them to collaborate together? There's also the issue of, well, if you're showing students that, hey, you're in a location that doesn't have so great internet, and you're constantly reminding them that they have issues with their connectivity, that could discourage students from participating in the course. And so in our white paper, we discuss a bunch of ideas of how to try and help students, allow them to be anonymous, allow them to opt into sharing measurements if they want, so that they don't feel obligated to do so, but sort of making it part of the general discourse of the class, we think is important. And then there's other challenges like, certain topics we can't discuss, like SDN and network management, and how do you grade this? How do you make a full curriculum out of it, et cetera? And then finally, we think there's aspects of this, other benefits that student measurements could provide. For example, having a sort of a global data set where students can contribute measurements to compare results across courses and sort of understanding what the state of the internet looks like, we think would be really cool. And then we also have ideas on how this user-centric networking, these measurements might even last after lockdowns are returning, and as Jim said, sort of entering this hybrid state of networking education. So we talk about that a lot in our white paper, and that's all. Thanks to our commenters for their feedback.
Great, thanks. So Larry, I'll kick it to you to start the discussion.
Yeah, thanks. So, man, this has been a great set of presentations, and I'm in the privileged position of getting to ask the first question. There's some coming in, get your questions on Slack, but listening to Keith's talk and all the questions he asked about how you put, what goes in the class, what doesn't, how do you teach, it's just, I think we all go through that every time we put together our syllabus, and you absolutely go through it every time you upgrade a textbook. And I mean, just an example of that is I struggle every time as to how much old stuff to take out when the history of how we did it, and then maybe we got it wrong, and then we figured that out, and then we got it right, is a value in itself. So how do you deal with that? So I'd just like to start by asking the other panelists, Keith, you can jump in as well, but how do you answer the questions for yourself and your students and your textbooks and so on? How do you answer those kinds of questions? And Jim, I got to go to you first because I know you've dealt with this scoping problem as much as anyone here.
Sure. Let me just say how much I appreciated all the talks, and Ross, the other Ross, Keith Ross, and I have these discussions all the time. We committed at the very beginning with our first edition that we were not going to write a 1,500-page textbook, and we're going to put something that's mostly digestible. So we always, if new things go in, you know, we started a whole new separation between the control and the data plane, a lot more on wireless. We had to take things out, and so you know, we took out things on some on network management, and so you do have to make those trade-offs. You said something, Larry, yesterday about students should be interested in history. That's always been my point of view. My co-author says absolutely not, and so since we argue about these things, he's usually the one who's better about taking things out, like there's nothing in multicast anymore. So you do have to take things out, and you know, this gets to Keith's question about, and when it was in his white paper, you just can't keep adding more and more in because students get overloaded. And I'll give you a personal example. When I first started putting my lectures online, I told students, oh, look, now you have all the material on all my lectures from last semester online. So we're going to do active learning in the classroom. We're going to dive down deep. What do you think of it? And I told them, we're going to do that in the fall for new students. So I want you to put yourself in the new students' shoes. And 80% of the students said that's a terrible idea because they don't have the time. And if what they really want to live and exist all the time was networking, it would be a great class, but they take 3 other computer science classes and they have lives outside of school. So we have to keep that set of material small. And I think it's individually how we choose what goes in there, but adding more and making it harder and making it deeper, that was one of the, you know, words of wisdom in Keith and Nick's paper. We've got to be very careful about that because we can't just say, oh, it's so important and there's more and more to do, because everybody says that about their discipline, right? So.
Yeah, at some point it becomes commodity and you just go buy it at Best Buy and then maybe you stop talking about it in a networking class. I don't know. Anyone else want to jump in on that one?
So I guess I would say a couple things here. So one of them is that at our school, we also teach in quarters, is the database community among the faculty actually split their course into 2. You know, so there's essentially a course that's pretty similar in many ways to the philosophy that Jen and Ross's class had, which is, okay, you're going to give somebody an introduction. What is this? To try to tell people what they need to know about networking, but not try to be an implementation-oriented class. You know, it's let's go explore it. Let's figure out how this relates to you. How does it relate to everything else? You can think of this as like what everybody should take, and actually that class gets taken by everyone. And it's early. It can be taken earlier in the curriculum because it has less technical material, the less implementation oriented. And then there is a separate class, which is let's go build databases from scratch, and let's just make a system let's give you the kind of implementation experience. And it just seems like there may well be this like ability to not try to squeeze both of those things into the same class, may be actually a way forward.
Thanks. Anyone else?
I'll just add that at UMass we did something similar.
Yeah, the user of versus the builder of is, I mean, I think operating systems has done something very similar.
So the other thing I was going to mention about, and this is something that Keith raised, which is this question about whether we do specifications for homework assignments or do we leave them open-ended. And I was like, be interesting to hear what other people say about this, but we've in the distributed systems class, which again is very technical. It's actually an implementation oriented class, but we have gone entirely towards just specifications. Like it's a problem if our specification is not precise, right? So we were trying to say, this is precisely what you need to implement. And, but of course, like this is the functionality that you need to implement, as opposed to this is how you're supposed to implement them. Now it turns out for distributed systems, that's complicated enough. It's like, oh, okay, go build a system that actually delivers packets from year to year. In distributed systems, like build something that's linearizable or something like that. I think I've seen, and again, this is like just something that seems pretty effective, is that if you want something that's open-ended, the better way to do that is to have a really open-ended part of the assignment. So I have a colleague who teaches operating systems, and the last assignment is basically pick your own assignment to go do. And just like, if it's totally open-ended, then that can work pretty well. But if you're going to give every student an assignment and the same assignment, then you really, I think the students deserve to say, this is the specification. We have a test case for it that will tell you whether you've gotten it or not. And that we ought to owe that to every student that we're teaching. It's like, this is this is the pass, and this is all you needed to do. You should be able to tell whether or not you've done the job.
Anyone else want to jump in? Keith, you're welcome to jump back into it.
Yeah, I'm thinking about this, Tom. We have a very detailed and nitpicky test suite, but I'm thinking back to my own undergraduate experience, and the best classes I ever took were like, it was a physics class, was one of the best, and we would get the seemingly impossible assignment, and you did have to show up and express your confusion and get coaching. And I always felt that this kind of one-on-one model was how learning really happened, trying to sort of meet students where they are. And I've always been, I don't know, it feels like dropping them, with like 500 pages of specification like you'd give if you were outsourcing the project. I feel like.
Yeah, I mean, maybe it's to some extent also related to the difference between these and topic area, right? So if I'm going to do a database, like, oh, okay, I'm going to say, here, go implement SQL, or this is the language to go support, and this is the property of it, and I will give you some kind of implementation-oriented question that requires me to be able to implement transactions correctly. It doesn't say anything about how I format those transactions or whatever. So it may be different in the kind of networking space where it's like, oh, okay, you have to implement this protocol. So it makes it more difficult.
I think
so the point that the personal experience Keith just raises actually connects the dots between this discussion and the pedagogy. So I would think specification oriented would be better in a as you scale, and the more you have to do one-on-one, obviously harder to scale.
So
I think that's true too.
Okay, I see Jim's face, so I'll go.
I was going to say also that I thought Keith's comment connected to pedagogy, but in a very different way than you just mentioned, Larry. And that is that I think that, we'd all probably die to have students like Keith in our classes, right? But they're not all going to be professors of networking at Stanford, right? And so, I'd mentioned earlier about this notion about contextualizing and personalizing to the students. And I think we do have to think about where are the students at, right? And what is it that's going to work for them? And as much as, I remember doing quantum mechanics assignments and not going to bed at night and how much I love that, I saw students who flailed and just couldn't do that or didn't want to do that, right? And so I think we have to be very careful not to project ourselves always onto our students. I mean, maybe some of them are like us, but some of them aren't.
The vast majority probably are not.
That's probably fair.
I mean, we all intuitively are in the business of trying to reproduce faculty at universities, which is probably not the right model.
I'd like to add something about the basics. So it has to do with the question of the slides from Ross. How much the basics and the specification kind of thing. This is an open issue because I do think you need the basics to understand how things work.
Yeah, Ross, it'd be good to hear your reaction to all of this.
Yeah, absolutely. I mean, we started out with like a clean slate approach and to see how far you can get with pure internet measurements and what can students understand. In terms of, building this out into a full curriculum, I think, yes, there needs to be some discussion of the basics at the beginning. They need to have a pretty general sense of sort of how layering works. Maybe Jen can touch on this a bit, but at the at Princeton's networking course, we sort of take a similar approach where layering is sort of quickly introduced in the beginning, and then sort of the rest of the course is devoted to design patterns and understanding like different choices for the networking, like networking infrastructure and how it fits into the layers, but how it also might touch across multiple layers. So there's definitely, I think, value in looking at designs more broadly than just going layer by layer.
Right, and I might echo what Tom said earlier, that there may be, you know, that very user-driven, curiosity-driven may work really well in one circumstance. So maybe for maybe a less, I don't want to say less non-technical, but you know, for people who want the broader perspective, they want to look at policy and net neutrality, and you want to sort of be able to motivate them that way, versus the people who want to get sort of down into the guts of the systems.
Yeah, absolutely. I mean, it's definitely, you know, hard to tailor a course for everybody. I've been sort of thinking that getting CS students more interested in learning about ethics and the consequences of their work is sort of generally important, and trying to learn how to integrate that into different aspects of CS, I think, is a worthy discussion.
Should we organize, let's say, since we, as a community, having pieces of topics, and that would, let's say, if you take the student take ABC, so you're more oriented, so you get the class and you're more oriented to that. But if you take BCD, you get that. As a community, it can be done. It's difficult to do that alone at the university, but and then diverse the students, so let them choose what it's more interested for one or for the other, but they both have a broad idea what's going on. That's a question.
I think that's absolutely doable, Edmundo. I think the question is where do you get the materials to do that? And I think, again, that's a place to look online, right? Because it's not like everybody's going to take a systems approach to networking, or a top-down, or a bottom-up, or a middle-out, or a user-driven, that people are going to want to do it different ways. They're going to want to contextualize it for their students. And so if you have materials online, if there are materials online, then I think what you do is you pull different pieces from different places. I mean, I'd love to, you know, be able to get some online material on net neutrality, you know, for example, or something that's, you know, right now on security from a voting perspective, right? That's what's going to really draw the students in.
Yeah, that's a great point. And I'm just thinking we're focused on how constrained our one course is, but curriculums are equally constrained. So you can't have you don't get arbitrarily many variations of the networking class, but across all universities, perhaps you do, and it gets sliced and diced differently. And I think that's kind of what we were talking about with the community resources a little bit yesterday. Build your own class from the combination if we only had that collateral.
Right.
So perhaps a hot take or whatever, but it's hard for me to see that there's a huge amount of evidence that the variety of different ways that we teach classes is actually effective for students. Like that there really is a big difference, like a really significant difference by my teaching it this way and somebody else teaching it that way, or that our students are that much different from each other that we have to have these differences. I mean, I know we do. It's partly like we do it because that gives us some creativity control or whatever. I think primarily that difference is for us and not necessarily really a huge benefit for students.
Oh, you've just asked the question of the session here. Now, how do we answer it? Of course we do it for ourselves.
Yes.
So, you know, I will, let's see, we're recording this, so I'm not sure I want to say it. But what I could say was, I think you're right, Tom, it doesn't really matter that much whether we teach it bottom up or top down or systems or inside out. But what I do think really is a difference is that different faculty at different schools have different kinds of students in their classes, and those students have different needs. And that's where the personalization that an instructor does makes a really big difference.
Yeah, sorry. I do apologize for interrupting, but but this actually I think is exactly right. I mean, I think it's in some ways we underestimate the notion that what universities primarily do is to accumulate a group of people together who have the same background so that we can teach them essentially the same way, and that's a much more efficient thing to do than if we had students who had a really like hugely diverse background and we have to figure out, okay, this is the pace at which students learn, or this. I think what we often fall into a trap of is thinking, okay, the students who don't have the same background or whatever aren't able to learn the material that we can teach them. I don't think that's true. I think there's a lot of evidence that if you do actually, collect a group of people who have the same background and essentially the same pace of learning, then you can be effective at getting them to the same place that the other students are. But it's certainly a lot more efficient if you have students who have essentially are similar in some way.
Well, and again, I'll come back to the issue that Keith brought up, that even among students who have similar backgrounds, not all of them have the same amount of intense interest. And so not all of them are going to want to get into the depth of debugging a SIG fault or something like that, right? And so we do have to be careful to just, even among a group of pretty homogeneous students, remember that there's different levels of interest.
So I wanted to,
okay, go ahead.
all right, so back to Tom, sorry. So I thought where you were going to go, Tom, is that as you scale is going to drive you to homogeneity. And maybe that's not what you're arguing?
No, I think that's true. I mean, I think that there's little evidence, little concrete evidence. I mean, maybe the anecdotal evidence that, hey, the way that I teach this class is so much better than the way that somebody else teaches some class, that's, a significant difference or something in that. I think there is a bit of evidence that there was some experimental evidence that if you look at like income levels of students who go to R1 schools versus income levels that go for students who go to R2s or teaching colleges, that those are really different even for people who get CS degrees or for engineering degrees. There was a big study done in Texas along these lines. And so it does seem like there is something that we are actually offering students by teaching them what we're teaching them. I'm not trying to disagree on that part, but it seems, it doesn't really feel right to say, exactly how you would go about doing this. And maybe standardization would help us quite a bit. Standardization works really well at K-12. It's like, oh, Jim is about to disagree. So go ahead, you can disagree.
No, go ahead. Then I'll disagree.
Well, I was pretty much done, so that's fine. That maybe by standardization we have more of an ability to share than we would otherwise, and more of an ability to scale, which I think is what Larry was saying.
I would advocate. I think heterogeneity is good. It's good to have also has its advantage. I understand the problems, but it has advantage as well. And if you promote interaction of the student, if you have the ability to do that, I think it's beneficial for everyone and works well. So I like when the things are mixed.
Yeah.
So I have to tell the story of when I took networking as a grad student. And I ended up obviously loving the discipline despite the class. We spent the entire semester learning different ways to implement CRC in hardware. And that was which is to the point, the class is taught according to what the instructor's interests are. And that's somewhat inevitable, but obviously we now have an opportunity to share more and benefit from other stuff that's online. That probably didn't help move the discussion along, but I couldn't help but think of specialized versions of the class. So let's see, we have a few, well, actually we're getting pretty close to the end of the time here. So any other final comments?
I just wanted to make one comment again about the issue of standardization or homogeneity, right? And I think that, we had a long discussion yesterday about textbooks. I think textbooks, another word might be generic, right? So, a textbook if it's going to be adopted by a large number of people, it's by definition generic, right? It's sort of one take. And I think when that's sort of necessary to achieve scale, but I think that, again, maybe I'm just repeating myself, that the ability to personalize and choose material that fits the students who are in the class is what's the critical thing. And, you know, it may be different from UMass to UMaryland, even though in many ways, I suppose they're sort of equivalent schools. I still think that the students who make up that class are going to have different interests. And so you're going to want to personalize it some. If we don't do that, well, I just think we have to.
And on that note, Jen, do you have any other wrap-up comments?
No, this has been a really great discussion, and the discussion on the Slack has been great as well. So I think we should let our organizers, Jim and Matt, conclude.
Yep, I agree. Thanks. Thanks, everybody. It's great panel.
Thank you for organizing this.
That's
Great.
Thank you.
Thanks.
Okay, so Matt, I see you're online. We should wrap up. Actually, I think maybe Matt and I didn't quite do our homework to figure out how we're going to wrap this up. Maybe I'll start off simply by saying, first of all, we want to thank everybody. You know, the series, this is the fourth in the series of the SIGCOMM education workshops, and they've just generally happened because people are interested, and you know, not because they happen every year and not because we necessarily get credit or whatever for them, but we do that because we're part of a community that cares about this. And it seemed like a good time to be having a workshop. And I'll tell you, the response has really been phenomenal. We've had just a tremendous number of people participating, and it's summertime, it's vacation time, and yet we're able to put something together really quickly. And so many hands went into making this. So thank you again to, first of all, to the sponsors, to SIGCOMM, and thanks to AMLS, who helped us really so well navigating with Zoom. Thanks to the session chairs, all the people who wrote white papers, and all the people who've been participating in this. That you know, Matt suggested we do Slack, and I'm like, oh, you know, he's a young guy, I'm an old guy. I'm like, Slack, okay, sure, if you want. But wow, that's just been phenomenal. So now I'm really a Slack convert, and there's just been such great conversation there, and it's great. It's gonna persist. And so there's been a lot of rich material and a lot of rich discussion. We're hoping to be able to synthesize it again through these two Google Docs. So please contribute to those, and continue to contribute on the Slack. Let me say also that we are going to be posting, as we said, the videos from all of the sessions. We're going to edit them down a little bit so that they're individual sessions, and then we'll also include the evening conversations that we've had as well, and we'll post those on the website. So if you come 2 weeks later and think, oh, I heard this really good idea that Keith said, you know right where you can go to get that again. So with that, I think this website will continue to be a resource, and my sense is this community as a whole really wants to get together and create more resources and make sure we share those resources, whether they're, you know, programs and software, or whether they're teaching tips and how to do pedagogy. So let me turn things over to Matt.
Yeah, I just want to echo what Jim said. It's been really great hearing all the ideas. I learned a lot. Really enjoyed interacting with everybody, and it'd be great to keep in touch. We're gonna probably be sending out a poll later today, just kind of asking for, you know, any additional feedback y'all have. And there's the Google Docs we can keep collaborating on. One thing that Steve mentioned on the Slack was this, CCR now has this education series. So if you're interested in publishing educational articles in the future, you can submit to CCR, and there's actually an educational track. So it'd be wonderful to have submissions there as well. But yeah, that's great.
And Matt, do you want to say just a word about maybe it's not public yet. I've seen the draft of the revamped education, SIGCOMM education website.
Oh, right. Yeah, we've been working on a revamped education website. If you go to education.sigcomm.org, there's a new website there. We're starting to put together some material On resources, for example, there is a resource page. It's quite bare bones right now, but we'll probably be adding stuff in from the Google Docs to improve that, and getting some better infrastructure there too. Of course, there's also an advice page. We tried to collate the, there's so many great advice articles online that people have written, advice for grad school, advice for new faculty, and so we tried to put together a page on that as well, and some other sources. So if you go to education.sigcom.org, there's some various resources there. And you can email me if you have ideas for other resources. There's like a contact email address on there, so that would be very helpful as well.
Okay, great. Well, I think with that, golly, my clock says exactly 12 noon, so we're right on time. Thank you again to everybody, and I'm sure we will all continue to see each other sort of around online and maybe even in person someday again. Okay. Bye-bye.
Thanks. Bye-bye.